In this video, we'll create a custom side menu using Rive animated icons from scratch and bring together everything we've built so far. The animated bottom tab bar, the main home UI, the onboarding screen, and the sign-in model to complete the application. Before we dive in, huge thanks to the original creator of the app, Design+Code. This project is inspired by the SwiftUI plus Rive course created by Mengto. In the course, he walks through building the same app using SwiftUI and also teaches how to create your own custom Rive assets using the Rive editor. It's completely free and includes both videos and articles. I highly recommend checking it out. I'll link it in the description. So first, we'll generate the side menu component. Then I'll change the selector name and import all the components and modules we'll need for it. After that, make sure to import the side menu component into the root course Rive page. In its HTML, add the side menu tag with an ID and temporarily comment out the main content and the bottom tab bar. Now inside this side menu HTML, we'll start with an empty div that uses the class side-menu, which will take up 100% of the dynamic viewport height or DVH. We're using DVH instead of VH because it works more reliably on mobile Safari. Next, we'll set the background color using a variable from our global theme. Then we'll add top and bottom padding to account for the safe area insets. Next, in the HTML, we'll add an Ionic row with the class header. And inside that, we'll place the person outline icon. It's showing up, but it's black. So let's change the color to white. Next, we'll add the user's name and designation inside an Ionic column. Use a BR tag to display them on separate lines. And apply a padding of 12 pixels to the header div. Now to style the user icon, we'll give it a background color, padding of 12 pixels, a border radius, and a right margin of 8 pixels. Then we'll align the header content to the center. For the designation text, let's apply a slightly dimmed color. To show the side menu buttons, we'll add a div with the class section-container. Inside it, we'll create another div with class menu list section, which will contain first section of buttons. Add a section title called Browse and apply the subheadline to font variant from our global theme. Next, we'll give this section title a slightly dimmed color and some horizontal margin. Now we'll create a new file called sidemenu.ts inside the models directory. This will store all the buttons data for the side menu. Then paste in the data for each section with their respective properties. Make sure to use exact property names. For example, the state machine name for home is home_interactivity with a lowercase I, but for other buttons, it starts with a capital I. Since we'll have multiple buttons, let's create a reusable component called menu row. In the component, change the selector name and import all the components and modules we'll need. Each menu button will get its own data from the parent, so we'll accept an input called menu. Now import the menu row into the side menu component and create a local variable menu items using the dummy data we added earlier. Finally, in the HTML, use the menu row tag and pass in the first menu items as input. Then inside the menu row component HTML, clear out the default content and start fresh with an empty div. Add an Ionic row with the class menu button container. Inside that, add a div to contain the Rive icon. Give it a fixed size of 32 pixels. Inside the canvas, set the state machine and the Rive input using menu status property as the value. Then add the button title next to the icon. In the CSS, we'll add padding to the menu container. Align the items to center and set cursor to pointer. Fix the icon dimensions to 32 pixels and give it a right margin of 14 pixels for spacing. We'll also apply opacity 0.6 to dim it slightly and set pointer events none so the icon doesn't intercept clicks. Now the button is almost ready. To render the rest of the items, use an ng for loop and make sure to use track by to provide unique ID for each item. Finally, replace the hard-coded menu input to instead use the one from the list. Now if you notice, some icons aren't rendering properly. That's kind of a limitation with the plugin right now. To fix that, we'll render each icon with a slight delay. In the menu row component, conditionally show the canvas only when a local show property is true. And now the icons are rendering properly. Next, Let's make a few layout changes to give it a more of a sidebar look. We'll set a fixed width, say 288 pixels, with a border radius of 30 pixels. In the menu component, we'll also add a separator between each button for better visual clarity. Now, to highlight the button that's selected, we'll create a div with the class menu-button-bg and give it a blue background, a height of 56 pixels, which matches the 32 pixels icon height plus the 12 pixels of vertical padding from top and bottom, and a border radius of 10 pixels. Set its position to absolute so that it appears behind the button content. It's not showing up yet, so we'll conditionally assign the background width if the current button's ID matches the selected menu, defaulting to home. We'll set its width to 272 pixels, that's 288 pixels, the sidebar width, minus 16 pixels of padding on the end. Otherwise, we'll set the width to 0. Now the background shows up, but it's covering the button text. To fix that, we'll add a Z index to the text element to bring it to the front. Let's also add spacing to the list of buttons. Apply a margin top of 40 pixels to the section container. Then wrap each menu row with a parent div. And apply padding, a margin top of 8 pixels, and position relative so the absolutely positioned background is relative to this div. Now, to trigger the icon animation on click, along with any other visual effects, we'll need a click event on the button. So we'll create an onPress event emitter in the menu row component and emit it when the button row is clicked. In the side menu component, we'll define a function called onMenuItemPress to listen to this event. The function will receive the button index and the selected menu item. Then in the HTML, call the function on the onPress callback. Inside the function, we'll set the status property of the clicked item to true. This works, but it causes the animation to keep playing in a loop. So to prevent that, we'll reset it by setting the value back to false after a 1 second timeout. That way, it only plays once per click. Now that we're getting a callback on the button click, next we'll animate the background. First, give the menu row tag an ID, something like menu items. Since it's a list, we'll use viewChildren to get a reference to all the menu items. Inside the onMenuItemPress function, access the array of element references and use a for loop to iterate through them. To perform the animation, we'll import Ionic's animation controller and define it in the constructor. Inside the loop, create a new animation for each menu item, target the element with the class name we gave to the button background, set the duration, and use from_to function to animate the width from 0 to 272 pixels. Finally, call the play to trigger the animation. Now the animation works, but it's being applied to all the menu items. So we'll add a condition, only animate the item if its index matches the one that was clicked. This improves it, but now the previous button's background stays active, so we need to track the selected item. Create a local variable selected menu and set its default value to the first item. Update this value whenever a button is clicked. Before updating it, also store the previous selection's index. Now in the loop, we'll update the if condition, trigger the animation only if the index matches the current or previous selection. Still, the previous background doesn't animate out. So we'll update the from_to values conditionally. If the item is currently selected, animate from 0 to 272 pixels, and if it's the previously selected item, animate from 272 pixels to 0. This creates a clean in-out animation. To smooth it further, let's provide a custom easing value using cubic Bezier for a softer curve. Next, we'll build the second section of buttons using the same logic. Declare a new array called menuItems2 and add the history section inside the HTML using this array. Assign it a new ID like menuItems2. To work around the same Rive icon rendering issue, we'll delay the rendering just like we did with the first section. Now the button animations work, but the background doesn't animate for this second section. So we'll get the references for this second list using viewChildren and merge both sets of references into a single array. Now the animations work across both sections, but we also need to adjust the last selected index logic. If the previous item isn't found in the first array, then get its index from the second array and add the length of the first list to offset it. And now everything works as expected. Finally, we'll add the dark mode toggle button at the bottom. Start by declaring a third menu items variable, which includes just one item in the array. Next, in the HTML, add an Ionic item element that contains the Rive icon canvas on the left and the toggle button on the right. We'll apply the font headline variant from our global theme, set justify input to space between and use iOS mode, and label the toggle as dark mode. Now the Ionic item comes with some default styles. So we'll add a class called dark mode container and set its background to transparent. At this point, the text and toggle track aren't visible clearly. So we'll fix that by setting the text color to white and giving the toggle track a slightly dimmed white background. Next, wrap the canvas inside a div with the class icon container. Set its dimensions to 32 pixels, add a right margin for spacing, and slightly dim the icon color. Also apply pointer events none so it doesn't intercept clicks. To shift the dark mode toggle to the bottom of the sidebar, add a spacer div just above it and give it a flex of 1. This alone won't work, though we also need to make sure the main side menu container has display flex and flex direction of column. Lastly, tweak the padding on the toggles container so it aligns neatly with the rest of the sidebar content. Now we'll handle the toggle logic. Declare a local variable isDarkMode set to false by default. Then create a function called onDarkModeToggle inside it and assign the value of isDarkMode to the dark mode menu item's status property. In the HTML, bind isDarkMode to the toggle using ngModel and attach the onDarkModeToggle method to the ion change event. Now, whenever the toggle is turned on, the dark mode icon will animate. Finally, don't forget to render this item with a slight delay, just like we did for the other buttons, using the menu item's show property. Now that the Sidebar UI is complete, let's make sure it is responsive across different screen sizes. It looks good on desktop, but on smaller screens, the content isn't scrollable due to limited vertical space. So to fix that, we'll add overflow via scroll to the section container. Optionally, we can also hide the scroll bar to keep the UI clean. And with that, our sidebar layout is done. Next, let's bring everything together, integrating the sidebar with all the other modules we have built so far, the onboarding flow, bottom tabs, and home screen. First, go back to the root course Rive component and uncomment the main content and bottom tab bar. You'll see that the sidebar now overlaps the home screen, so we need to fix that. Set position absolute on the content, but you'll notice the text and icons are still showing above. So we'll also assign a Z index to the content container. Now, to ensure that the bottom tab bar appears on the top, assign it a higher Z index, for example Z index of 2. Next, we need a way to open the sidebar from this screen. For that, we'll use a Rive asset that has two states, open and close, toggled using an input called isOpen. The process of creating this animation in the Rive editor is explained in detail in the original Design+Code course, so be sure to check that out. In the HTML, we'll add a Rive canvas with the file name menu_button and set its size to 44 pixels. Inside the canvas, add the state machine and bind the input named isOpen with a value of true. We'll make this value dynamic shortly. Now it's not visible yet, so we'll wrap it in a div with a class side menu button. Set its position to fixed and assign Z index of 2 so that it appears on the same layer as the bottom tab bar, above the content view. Then apply top to 16 pixels plus safe area in set top and left to 16 pixels for margin from the top left corner. Then a box shadow for depth, a white background so the shadow renders correctly, then display flags to fit the content, border radius of 22 pixels which is half of the button's 44 pixels size, and cursor pointer to make it interactive. Also add pointer events to none to the canvas so it doesn't block the click event on the button container. Now in the component, declare a variable called isMenuOpen to track whether the menu is open or closed. Create a function onMenuToggle and toggle the isMenuOpen value when the menu icon is clicked. In the HTML, bind isMenuOpen to the Rive input value, attach onMenuToggle to the button's click event. And now the menu button animation works as expected when toggled. Next, since the menu button overlaps the content, we'll add a top padding of around 60 pixels to the content view to create some space. And just like the other Rive icons, we'll also render this menu button with a slight delay to work around the plugin's limitation. Now it's time to animate the side menu and related UI when this menu button is clicked. First, assign IDs to the menu button, the content view, and the bottom tab bar in the HTML. Then in the component class, get references for all of them using viewChild. Let's start by animating the content view. Create a new animation function using animation controller and animate the transform from none to translate x of 288 pixels, which matches the sidebar's width. Now since we'll be running multiple animations together, create a group animation and set a shared duration of around 250 milliseconds. Now check the isMenuOpen variable. If it's true, call play to run the animation. It works, but then doesn't close the view when clicked again. So when isMenuOpen is false, call reverse to close the sidebar. And now the content smoothly opens and closes with the menu button. Let's enhance the animation further. Add a rotation along the y-axis, something like rotate y of -30 degree to give it more depth. It rotates, but it doesn't quite look right. That's because we're missing a perspective value. So add a perspective transform to give it that 3D feel. Now you might wonder where this perspective calculation comes from. It's actually adapted from a Stack Overflow solution that helps calculate perspective dynamically for different screen sizes. While there isn't a clear explanation behind the math, it seems to work well for our layout across various devices. Finally, add a scale down transformation to shrink the content slightly as it moves aside. Now that the content is transformed, it becomes harder to see clearly. So let's add a background behind it. In the HTML, add a div with the class screen background. Then in the CSS, apply a background color that matches the sidebar and style it to cover the entire screen area. To complete the look, apply a border radius of 30 pixels to the content and set overflow hidden to make sure the rounded corners work correctly. This gives the app a clean, polished depth effect. Next, let's animate the menu button itself so that it slides out with the content. In the onMenuToggle function, add a new animation for the menu button. Apply a transform of translate x of 216 pixels when the sidebar is open and pass this into the animation group along with the content animation. Now it moves together with the content, nice and clean. It looks good so far, but we can make it even better by animating the sidebar itself. Create a new animation for the side menu with the translate x in the opposite direction and rotate y of 30 degree, mirroring the content's rotation. For perspective, since the sidebar has a fixed width, a hard-coded value like 700 pixels will work just fine here. Add this to the animation group as well. And now the transition looks much better. Lastly, let's animate the bottom tab bar. Since it overlaps the sidebar content, we'll slide it down by 300 pixels using a translate y transform and include it in the same animation group. Now all the sidebar animations are working, but there's one last issue. The transformations from the animation controller only apply after the menu button is clicked. That means on initial load, the sidebar is still visible underneath the content. To fix this, we'll apply the same initial transform values directly in the CSS so the view starts in its animated position even before any interaction. Next, we'll integrate the onboarding UI into the full app. To display it, we'll add a new button with a person outline icon. Set its position to fixed with a top offset of 20 pixels plus safe area inset and a right of 16 pixels. Give it a Z index of 2 so it appears in the same layer as the bottom tab bar and the menu button. Then style it with a white background, fixed size of 36 pixels, flex properties to center the icon, border radius for roundness, a subtle box shadow, and for the icon we'll add a stroke width, black color, and cursor pointer since it is clickable. Now assign an ID to the button and get its reference in the component class. Since we want this button to animate out of the view when the sidebar is opened, We'll add an animation inside the on menu toggle function that moves it to the right by 100 pixels. And it works as expected. Next, declare a Boolean variable showOnboarding to control the visibility of the onboarding view. Then create a function showOnboarding toggle to toggle this value and call it in the HTML when the new button is clicked. Now, uncomment the CROnboarding tag in the root component. To make sure it sits above all content, we'll give it a position absolute and a Z index of 3 so it appears on top of the content view. Before we animate the onboarding screen, we'll add a close button to its layout. Inside the onboarding component, add a button with close outline icon. Then set its position to absolute with top based on the safe area inset and right of 16 pixels. To align it better with the onboarding content, we'll add an additional top margin of about 100 pixels. And for styling, update the background for normal, hover, activated, and focus states. Set its size to 36 pixels, remove default padding, add border radius and box shadow, set icon's font size to 24 pixels, and finally apply cursor to pointer. Next, let's create a custom event emitter to notify the parent when the onboarding screen is closed. Call it closeOnboardingEvent and emit the event from the closeOnboarding function when the button is clicked. Back in the parent component, listen to that event and hook it into a handler function. Before animating, we'll give the onboarding component an initial transform value of translate y minus 100% of the viewport height to position it off screen. Now for the animation, first assign an ID to the onboarding component and get its reference in the class. Now in the showOnboarding toggle function, create an animation that slides it from translate y of minus 100% of the viewport height to minus 100 pixels. This leaves a little space from the bottom for visual separation. Since we are animating multiple elements again, create an animation group and set the duration to 500 milliseconds. Play the animation when showOnboarding is true. It works, but doesn't animate out when we close it. So we'll add a reverse animation when showOnboarding is false. And now it transitions in and out smoothly. And to make it even better, add an easing of ease in out to the animation. Now let's polish the onboarding model style a bit to make it look more like a model. Apply a border radius of 30 pixels and don't forget to set overflow hidden to make the radius work. And a soft box shadow. Now it looks much cleaner and clearly separates from the background. As we show the onboarding screen, we'll also scale down the content view slightly. So in the same animation group, animate the content to a scale of 0.92, just a subtle zoom out. Lastly, animate the bottom tab bar by translating it downwards slightly. And now the onboarding screen flows in beautifully with everything synced and polished. Now the bottom spacing on the onboarding screen isn't quite aligned with the content scale. So instead of using a fixed value, we'll calculate it dynamically. Create a variable called transformBottom and initialize it with 100 viewport height. Then subtract the product of 100 VH multiplied with 0.92, where 0.92 is the scale applied to the content view. This subtraction gives us the remaining height not covered by the content, but it includes both the top and bottom spacing. So divide the result by 2 to get just the bottom part. Now it lines up perfectly with the content view. Apply this calculation value in the onboarding animation. To reveal a bit more of the content behind, we'll add an extra 20 pixels to the result. And finally, add it to the initial value as well. Add another 40 pixels to account for the box shadow area, making sure the onboarding is completely off screen when hidden. Now it works perfectly. But since the animation only triggers after interaction, we still briefly see the onboarding when first opening the app. To prevent that, Apply the same transform value in the CSS as an initial style. And with that, the onboarding integration is complete. Next, you might notice that when we open this sign-in view, the close button isn't in sync with the animation. So to fix it, give the close button an ID, get its reference in the component class, and in the enter animation function, animate it with translate y of minus 150 pixels so it slides slightly out of the view. Now that looks much better. We are almost done, just a few final touches. In the root component, let's add a white underlay behind the bottom tab bar. And in the CSS, set its position to absolute and anchor it to the bottom. Assign a Z index of 2 so it layers correctly. Then apply a top to bottom gradient background from transparent to a whitish color from our theme. Then give it a fixed height of 150 pixels and a full width, and set pointer events to none so it doesn't block any interactions. It adds a nice touch to the UI, but we should hide it when either the sidebar or onboarding is visible. So give it an ID and get its reference in the component. Then animate its opacity to 0 when the onboarding is shown. And do the same when the sidebar opens. And that completes the polish. Now let's run the app on Android as well. Now you'll notice that when the sidebar opens, the status bar text black color becomes hard to read on the blue background. Using Capacitor's status bar plugin, we can fix this by toggling the status bar style. When the sidebar opens, switch to dark style, which tells the system that the background is dark, so it automatically makes the text light and vice versa. And aside from that, the app works the same on the Android as well. But if you look closely, on Android the content renders behind the status and navigation bars, and it doesn't respect the safe area spacing the way iOS does. That's because we're currently using Ionic's built-in safe area variables, which only return values for iOS. So to fix that, I'm using a plugin that I created called Capacitor Status Bar Safe Area. It provides CSS variables for both platforms. On iOS, it gives you the usual safe area insets, and on Android, it includes the status and navigation bar spacing. Then make sure to run npx cap sync to sync the plugin and run the app again. Next, to be able to use the CSS variables from the plugin, we need to inject them. So in the root app components constructor, inject the variables using the plugin's setup function. Finally, replace all usage of ion safe area with the new safe area inset variables throughout the app. And now the app has much better spacing even on Android. Lastly, let's test responsiveness on desktop screens as well. Everything looks clean and adaptive, and the layouts seem to hold up well across the screen sizes. And with that, our application is complete. It runs on Android, iOS, and the web, and handles responsiveness and polish on all the platforms. If you found this tutorial helpful, please like and subscribe, and feel free to leave a comment if you have any questions, suggestions, or just want to say hi. I hope you enjoyed the tutorial, and I'll see you in the next one.